Then we have discussed about site selection criteria for rain gauge. After that, we have learned about various types of recording type of rain gauges. In that, first is weighing bucket type, where rainfall is recorded as rate of rainfall in centimeter per hour. Intensity of rainfall is recorded. In tipping bucket type of rain gauge, we know that we get the total value of rainfall, and this value can be obtained at a remote place. Okay, this instrument can be this rain gauge station can be established at a remote place, and the data is available at the control room, control station. So this is tipping bucket type rain gauge. Third is float or siphon type rain gauge, in which again we get the rate of rainfall in centimeter per hour, and the output of this rain gauge is in terms of the mass rainfall curve, which provides the data in centimeter per hour based on the time duration and intensity of rainfall. We can also work out what is the total rainfall for a particular day. Okay, so after studying all these types of rain gauges, now we will see what are the advantages and disadvantages of recording type of rain gauges. So let us start with the advantages of recording type of rain gauges. So what do you think? What is the advantage of this recording type of rain gauge? Okay, just now I have taken the review of recording and non-recording type of rain gauges. Now the point of discussion is what are the advantages of recording type of rain gauges? Okay, you can answer this question by comparing this with non-recording type of rain gauges. So what do you think? What is the advantage of recording type of rain gauges over the non-recording types? Yes, unmute and speak. Now you are aware of with the procedure how the rainfall is recorded in non-recording and recording. Okay, so from that you can answer this question. What are the merits or advantages of recording type of rain gauges? Yes.
Yes.
Who will answer this question?
रेनफॉल सर ऑटोमॅटिकली रेकॉर्ड केला जातो रेकॉर्डिंग
थोडं जरा मोठ्याने बोला, ऐकू येत नाही.
रेनफॉल ऑटोमॅटिकली रेकॉर्ड केला जातो रेकॉर्डिंग
Okay.
टाइप रेंगेज मध्ये.
Correct answer. The first merit is rainfall gets recorded automatically, whereas in case of non-recording type, the attendant is necessary. Every day attendant has to visit the rain gauge station. He has to measure the rainfall in measurement cylinder. So that is the process. So which is not necessary here. So attendant is not necessary. That is the first merit. Right answer. What is second advantage?
So possibility of human error is neglected.
Human error is neglected. Correct. Correct answer. Next. So in this case, intensity of rainfall is recorded. In non-recording type, the total amount of daily rainfall value is recorded. And here intensity of rainfall is recorded. Okay, both values are useful, but intensity of rainfall value is useful in order to predict the flood when the maximum discharge will reach at a particular point that can be worked out with reference to the intensity of rainfall, with reference to the time of concentration. It is time required to reach the runoff in a stream at a particular point or at the outlet of the basin. Okay, that is the importance of intensity of rainfall. Okay, then one more advantage is it can be placed at remote places. So every day there is no necessary to visit the rain gauge station. So it can be placed at remote places in hilly areas. So that is the one more advantage of recording type of rain gauge. And as explained by someone, possibility of provided. So these are the merits of recording type of rain gauges. What are the demerits of recording type of rain gauges? Yes, anyone? You know the construction of recording and non-recording type of rain gauge. So based on that, you have to answer this question. What are the demerits? So we know that in all these recording type of rain gauges, there is some mechanism used for the recording. Okay, so some error is possible in this recording mechanism, and due to that the wrong data may get recorded. If we compare the cost of both types of rain gauges, then of course the recording type of rain gauges are costlier. So they are costly as compared to non-recording type. Then fault may be developed in recording mechanism or electric mechanism. That electric mechanism is used in tipping bucket type of rain gauge. Okay, so these are the merits and demerits of recording type of rain gauges over non-recording type of rain gauges. Okay, now we'll discuss what are the sources of error in recording the measurement. Okay, this is related to both type of rain gauges, either recording or non-recording. Okay, what is the point? Sources of error in recording measurements. Is it clear? So what is the first point? Mistake in reading the scale of the gauge. We know that the manual attendant is necessary. So he visits that place every day at a fixed time. He removes the receiving bottle from the container and he pours the water in measurement cylinder and he reads the reading. So he may make mistake in reading the scale of the gauge. So that is first one. Dents in collector ring changes the collector area. So we know that the recording or non-recording type of rain gauges, both are having that circular collector area. Okay, and that circular collector area is this one is a metal part, and due to the repetitive use, the dents are developed in this collector ring, and these dents changes the collector area. So due to that, there is a possibility of development of sources of error in recording the measurement. Next to that, the initially funnel and inside surface requires 2.5 mm of rain to get moistened. So what this third point is, we know the construction of this any type of rain gauge. So it is having a circular collector. So here we can see this circular collector. Okay, this is a circular collector. Consider inside surface of this circular collector and inside surface of the funnel. So for initial moistening this area, how much rainfall is necessary? 2.5 mm of rain is necessary when it is dry. And this quantity goes annually up to 25 mm. Okay. So if we consider that for 10 times it becomes dry and after that rainfall takes place. So every time 2.5 mm of quantity is required to moisten the funnel and inside surface of collector area. Okay, so this should be considered. Okay, this should be considered, or this value should be added whenever necessary. Water splashed during measurement. So in non-recording type, we know that the receiving bottle is removed and the water is poured, rainwater is poured in a measuring cylinder, glass measuring cylinder. So during that, some water may be splashed out. So due to that, 1% of error occurs. Higher wind velocity. So we have discussed regarding the site selection criteria for rain gauge station. So rain gauge station should be properly shielded from higher wind velocity. So if higher wind velocity is there, then there is a disturbance and the appropriate rain will not be catched by the collector area. So this is the one more reason for source of error in recording. Then we know that all rain gauges are vertical. So if these rain gauges are inclined, okay, due to some reasons, then they catch less rainfall. Okay, and it is studied that if there is a 10% inclination, then this results in 1.5% of lesser catch. So 1.5% rainfall recorded, less recorded than the actual, if there is a 10% inclination to the instrument. Okay, so these are various sources of error in recording measurements. After this, we are going to study the next point, that is about the term rain gauge network. This is also known as rain gauge density. Rain gauge network or rain gauge density. Now on the screen, you can see a figure. So what this figure shows watershed. Okay, there is a large watershed, or this may be some tehsil or district map, and this area consists of number of watersheds. Okay, so these watersheds are shown by dotted lines. Okay, if you carefully observe, then there are the dotted lines, and this dotted line shows the number of catchments, number of drainage basins, number of watershed. So out of that, see, this is first watershed. Okay, this is first watershed. This watershed is having this primary stream, and this primary stream is fed by two more streams. Okay, and this star, okay, this symbol star indicates this is the outlet of the catchment, and we know that at the outlet of the catchment, the discharge is recorded. Okay, runoff is recorded. So likewise, this is the second catchment, and again at the outlet point, okay, there is a gauge is fitted. Okay, gauge is fitted on the stream, so it is a stream gauge, and this stream gauge similarly is shown for third catchment. See, this is third catchment. Okay, and after that, this is fourth catchment. Okay, these three catchments, 1, 2, and 3, they feed to fourth catchments. And see this star. Okay, I hope that laser marker is visible to you. Okay, so at this point, there is a star, and that is what? That is the outlet for the fourth watershed. Okay, this fourth watershed is fed by three more watersheds. Okay, along with it, it is supported by three more watersheds. So this is one area. This may be one map of Tehsil or maybe a map of district. And also here urban area is shown. You see the index to the right, index is shown. So urban area, we can see there are three places which shows urban area. Then the blue dots indicates the rain gauge stations. Okay, then there is a network of streamlines, and star indicates the stream gauge. Okay, R is radar location. So you know that along with this rain gauge station, okay, so radar can also measure the precipitation, and the extent of radar is shown by the red line. Okay, so this is a general map of one catchment, one large catchment which consists of four catchments. These four catchments combinedly they form a one large catchment. Okay, and now see this laser point. At this point there is an outlet of the catchment. So here stream gauge is established. What is stream gauge? Stream gauge is a place where the cross-sectional area of a stream is firm. Only the velocity is measured and cross-sectional area is multiplied with velocity. This is how the discharge is worked out. Okay, now let us come to the term rain gauge network again. Okay, there is a term rain gauge network or network density. There is one more term. Network density. Okay, so what is meaning of term network density or rain gauge network? So it is the number of rain gauges in a catchment area, or this network density is expressed as number of rain gauges per square kilometer area. Okay, this is how network density is expressed. Now, what is the importance of rain gauge network? During practicals, we have seen that for various purposes, we need the average annual rainfall value. Okay, or we need the average precipitation value. This average precipitation value may be worked out daily, it may be worked out seasonally, or it may be worked out annually. In order to calculate this average precipitation value, average rainfall value, there should be optimum number of rain gauges in the area. If the number of rain gauges are optimum in the area, then and then only they provide the accurate value of average precipitation of the area. So there is a need of calculation of optimum number of rain gauges required in a catchment area. So now we are going to learn how to find whether available number of rain gauge stations in the area are sufficient or not. Whether available number of rain gauges are optimum number of rain gauges for that area. So that we are going to learn now. Okay, so the term is the rain gauge network or network density. And what is rain gauge network or network density? It is the ratio of total area of the catchment in square kilometer to the number of rain gauge stations in the catchment. Suppose total area of the catchment is 100 square kilometer and number of gauges in the catchment are 2. Then network density is 1 gauge for 50 square kilometer. Okay, this is how the term network density or rain gauge density is worked out. Now, there is a World Meteorological Organization, and this World Meteorological Organization provides recommendation for number of rain gauges based on topography of the area. So everybody observe this table. So according to World Meteorological Organization, the entire Earth surface is divided into three regions. One region, region 1, number 1 is given to the area having flat region or of temperate, Mediterranean or tropical zones. Okay, flat region of Mediterranean or tropical zones, that is considered as region 1, and in that case suggested network density minimum required is 1 gauge for 600 to 900 square kilometer. Okay, for region 2 is defined as a mountainous areas of temperate, Mediterranean and tropical zones. There is a Mediterranean Sea, the area around the Mediterranean Sea and the tropical zones are included in region 2, where the network density required, minimum required is 1 gauge for 100 to 250 square kilometer. And in exceptional case, the tolerable value is suggested as 1 gauge for 250 to 1000 square kilometer. The third region is arid and polar zones. Okay, polar zones and arid zones, they are classified as region 3, in which the 1 gauge is suggested, minimum 1 gauge for 1500 to 10,000 square kilometer. Okay, so these are the recommendations by World Meteorological Organization. Also, they suggested that 10% of the total rain gauge stations, 10% of the gauges should be of recording type. If there are 10 rain gauge stations in the area, in that case, one should be of recording type. Now, on the basis of these recommendations given by WMO, the recommendations are decided for the Indian conditions. So there is IS 4987 1968. According to this IS, recommendations are as follows. Number 1 is 1 station per 520 kilometers, and it is for plain areas. If there is a rolling terrain, if almost plain area is there, in that case 1 gauge or 1 rain gauge station is sufficient for 520 square kilometer. Now, if the Earth surface area is having the average elevation of 1000 meter, okay, if the elevation of the area is 1000 meter. Now see, elevation of Kolhapur is around 600 meters. Okay, so if the elevation of the area is average 1000 meters, in that case, it is suggested to provide 1 rain gauge station per 260 to 390 kilometers square. And if it is a totally predominantly hilly area is there, and if there is a heavy rainfall, then 1 rain gauge station is suggested for 130 square kilometer. And similar to WMO, 10% of rain gauges should be of recording time. Okay, so this is about the IS recommendations for the rain gauge network. Now we will discuss about calculation of optimum number of rain gauges. Okay, so we know that in order to estimate the average precipitation or mean rainfall of the area, in that case, there should be optimum number of rain gauges. And there is a statistical formula with help of which we can calculate these optimum number of rain gauge stations. Now the formula is N is equal to bracket CV upon P bracket square. So here N is optimum number of the rain gauge stations. P is allowable degree of error in estimation of mean rainfall, which is expressed in percentage. Whereas CV is coefficient of variation of rainfall values at existing N stations. Okay, here it is M is written as, but this is small n. Okay, instead of M, let us use this symbol N. What is N? N is existing number of stations. So now it is expected that you have to note down this formula, and then we are going to solve problems on this. So all of you are asked to note down this formula. Very few students are in the meeting. Okay, only 9 students are there. This is very bad. Are you writing this formula?
Yes, sir.
Reply me.
Yes, sir.
Yes.
Okay. All of you, please note down this formula. This formula is regarding calculation of optimum number of rain gauges. What is importance of optimum number of rain gauges? Its important is if number of rain gauges are optimum, then the calculated average precipitation value is more accurate. Is it clear? That's why we have to find out how much optimum number of rain gauges are required in a particular area. And for that, we have to take help of the values of rainfall at existing n number of stations. Okay, this is a statistical formula in which we have to find out coefficient of variation of rainfall values of existing station. And we have to find out this optimum number of rain gauges for some allowable degree of error. Okay, so this allowable degree of error may be 5%, 6%, or it may be up to 10%. So for this allowable degree of error, which is expressed in percentage, and this allowable degree of error is in estimation of mean rainfall. Okay, this much error is allowed. So on that basis, we have to find out capital N, that is optimum number of rain gauges required in an area. So formula is N is equal to CV upon P bracket square. Okay, so below that you note down what is N. N is optimum number of rain gauge stations. Note down P, allowable degree of error in percentage. And note down CV. What is CV? It is a coefficient of variation of rainfall values at existing N number of stations, which is expressed in percentage. So P and CV both are expressed in percentage, and that's why N is number. Okay, so the first formula is CV upon P bracket square. So I hope you have noted what is N, what is CV, and what is P. CV and P is expressed in percentage. Now we'll see how to calculate CV. So CV is calculated with the formula Sx upon x bar into 100. Okay, so the answer will be in percentage. So in this formula, what is Sx? Sx is standard deviation. Of rainfall values. And what is x bar? X bar is mean of rainfall values. Okay, so if we calculate Sx and x bar, then we get CV with this formula Sx upon x bar into 100, and it is expressed in percentage. Then P is assumed, okay, allowable degree of error is taken as either 5%, 6% or 10%. Now next is we will see how this standard deviation is worked out. So to calculate standard deviation, formula is Sx square is equal to summation of xi minus x bar bracket square divided by n minus 1. So here what is x bar? It is clear to you, mean of the rainfall values. What is xi? Xi is rainfall value at each index station. Rainfall values of index or existing stations. Okay, so from this formula we get Sx from Sx square, and from Sx square we have to calculate Sx, and we have to put this value here. Before that we have to calculate x bar. How we calculate x bar? What is x bar? It is the mean of rainfall values. So how this x bar is calculated? X bar is equal to summation of xi upon n. Okay, summation of all rainfall values of existing stations divided by number of existing stations. So from this we get x bar, and when we get x bar we can calculate sx square. From sx square you calculate value of sx, and from sx and x bar you calculate cv and put the value of cv in main formula, and then you get n. N is optimum number of rain gauges. Now if your calculated n is greater than small n, then what it indicates? Small n म्हणजे काय? Existing number of rain gauge stations. Capital N म्हणजे काय? Optimum number of rain gauge station. So if optimum number of rain gauge stations are more than n existing, then what it indicates? It indicates that additional rain gauge stations are necessary. So what are how much additional rain gauge stations are necessary? Additional rain gauge station necessary are optimum number of rain gauges required minus existing number. Suppose optimum number value is 8 and existing number value is 6. So additional number of rain gauges required are 2. Okay, so this is how we can calculate whether the available number of rain gauge stations are optimum or not. If not, we can find out how many number of rain gauge stations should be added in existing number of rain gauge stations. Okay, and if the value of n, capital N, is less than small n, then what it indicates? Calculated value is less than existing value. Suppose calculated value is 5, existing value is 6. So it is more than sufficient. Okay, so here no additional rain gauge stations are required. Is it clear? So all of you note down this slide. Already you have noted down the formula for n and notations used in this formula, its meaning. So now you note down CV, Sx square formula, x bar formula, and you write what if n is greater than small n? What if n is less than small n? And based on this, now we are going to solve some problems. I hope all of you are writing all this. Is there any doubt related to calculation of optimum number of rain gauges?
No, sir.
Okay. Have you completed the write-up?
Yes, sir.
Okay, so using these all formulas, now we are going to solve one problem. Shall I go to the next slide?
Yes, sir.
Everybody note down this problem. Okay, I will read the problem. A catchment has 5 rain gauge stations. The first line is catchment has 5 rain gauge stations. So which value is given in the first sentence? Tell me. A catchment has 5 rain gauge stations. So which value is given here? The value of small n is given. Okay. Value of small n is 5. A catchment has 5 rain gauge stations. Existing number of rain gauge stations are 5. In a year, the annual rainfall recorded by the gauges are, okay, now the rainfall values are given. Okay, so this is denoted by xi. Okay, x1, x2, x3, likewise these values are there. Rainfall values. In the second line, it is 78.8. In a year, the annual rainfall recorded by the gauges are 78.8 centimeter, 90.2 centimeter, 98.6 centimeter, 102.4 centimeter, and 70.4 centimeter. For a 6% error in the estimation of mean rainfall, determine the additional number of gauges needed. Okay. So tell me, what is this 6% value is? What is notation for this? Tell me. For a 6% error in estimation of mean rainfall.
P.
Yes, it is P. So P is 5%. 6%, sorry. For 6% error in estimation of mean rainfall, determine the additional number of gauges needed. Okay, so what we have to calculate? Additional number of gauges needed. Capital N minus small n is equal to how much? Out of that, small n is 5. We have to find out capital N. What is formula to find out capital N? It is CV upon P bracket square. Okay. And in that we have to calculate CV. P is given. To calculate CV, we know that, so you have all the formulas now in your notebook. So what is CV is equal to? It is Sx upon x bar into 100. So we have to calculate now x bar and Sx. So let us calculate x bar. X bar is equal to what? It is summation of xi upon n. What is summation of xi? It is summation of rainfall values of existing stations. There are 5 existing stations. Let us calculate their summation and divide this by n number of existing stations, that is 5. So this is how you calculate x bar. What is x bar?
$88.08.
88.08 काय?
8.
8.
हाँ.
Okay, now we have to calculate Sx, and for Sx formula is Sx square is equal to summation of xi minus x bar upon n minus 1. Okay, hence for Sx square, now we can write what we have to do, summation of xi minus x bar. So what is xi? That is value of station 1. Okay, it is bracket square 78.8 minus x bar is 88.08 bracket square. Okay, it's a summation, so plus second station value is 90.2, that is xi minus x bar 88.08 plus third value 98.6 minus 88.08 bracket square plus fourth value 102.4 minus 88.08 bracket square plus fifth value 70.4 minus 88.08 bracket square. Okay, so this is summation of xi minus x square divided by n minus 1, which is 5 minus 1, that is 4. So from this you get Sx square, and from that you calculate the value of Sx. So everybody calculate Sx, and from that we will calculate what is Cv. Because Cv is Sx upon x bar into 100. Calculate Sx, hence calculate Cv, hence calculate n. Put the value of Cv in the formula. N is equal to Cv upon P square. If you have calculated Sx, then tell me the value. Calculate Sx. Now see, this is the solution. You have calculated x bar, it is 88.08. Okay, from that we have to calculate Sx. So if you see, the answer for Sx is 13.41. And then Cv is equal to Sx upon x bar into 100. Answer for Cv is here 15.22. And then n is equal to Cv upon P bracket square. So this answer comes out to be 6.43, and it is approximately equal to 7. Okay, and what is n? N is 5. Small n is 5. So here capital N is greater than small n. So in this case, additional number of rain gauges are required. And here additional number of rain gauges required are capital N minus small n. So capital N is 7, small n is 5. So additional number of rain gauges required are 2. So that is the required answer. 2 additional rain gauges are required. Then only the calculation or estimation of average precipitation is possible with 6% allowable error in estimation. Is it clear? So everybody note down the answers. Okay. So this is solved problem from a book. Similar problems are asked in the examination for 4 to 6 marks. Okay, such a problem will be there, and you have to find out how many number of additional rain gauge stations are required. So for that you have to calculate at first x bar. From x bar you have to calculate Sx. From Sx you have to calculate n. and from capital N you have to calculate additional number of rain gauges required. So this is the solved problem from a book. So you see the last year question papers, in that you will found this question in question number 1 for 4 to 6 marks. Okay, so with this, wait a minute, I have to download the attendance.